Hello class, Ms. Fiorillo here, going to talk about rotating shapes about a point. The point I'm going to use is the origin. Now, if you had a center rotation, anything other than the origin, I would just pretend it's the origin, draw new axes, and this same process, the same method will apply to that. So first I'm going to talk about how to rotate B 270 degrees counterclockwise. So 270 degrees would move it 3 quadrants. That would be about 90, 180, right? 180 would be halfway around a circle, and then 270. So when you rotate something 270 degrees, it's going to move 3 quadrants in that direction. Now, rotating 270 degrees counterclockwise is also the same as rotating 90 degrees clockwise. Now, one way to do these rotations is to memorize the point mapping. So any x, y point, so like -3, 2, will map to y comma -x. So that's saying your x value will now be your y value. So that means if the y is 2 here, my x value will be 2. And then it says now your y value is going to be the opposite of the x value you had. So if the x value was -3, now my y value is going to be +3. So that's where my b prime should end up. And I'm just going to call it E because it takes too long to rename them. Now, another method you can do instead of just figuring out the point mapping is more visual, and it's to imagine, or actually even draw if you can't envision it, a rectangle in which 2 of the sides are the axes, x and y, and the point is one of the corners. And it's much easier to visualize this rectangle rotating 90 degrees clockwise or 270 counter. I always like to pick the smaller one. So imagine if I just put like a push pin right on F and I could rotate this rectangle around. My rectangle would then look like this. It wouldn't be 3 by 2, it would be 2 by 3. And that's how the rectangle would rotate, making my point B, which is in this right corner, over here. And there's B. So I like the rectangle method because there's no memorization. You just envision a rectangle and you envision it rotating. Now, something I want to show you is that if I draw a line from the origin to my pre-image point and my image point, and I measure that angle. So let me click the measure tool, and I measure this angle. See how it's 90 degrees? Now, if I measure this distance, the distance should be the same. That's what it means to rotate. It rotated 90 degrees, and it's the same distance away from your origin. It's kind of like an orbit. And you can really visualize the orbit if you draw a circle. So like you could also do this with a compass and go 90 degrees with a protractor along the circle. So if I rotate point A, I clicked the wrong thing. If I rotate point A prime, or its image, will be somewhere in this orbit, just like planets. It's going to be 90 degrees over here. Now, if this is 3 and 4, I know I'm going to end up in this quadrant with a rectangle 4, 3. It's going to end up right there. So there's A prime. Just call it G. Now, D is 5, 4. So it's going to be 4, 5, 2, 3. It's going to be right here. And if I draw a circle, from the origin, they should be in the same orbit. And they are. They're all in that circle. Same distance away from the origin. And lastly, C, point C is 6, 3. So it's going to be 3, 6, but in quadrant 1. Got to zoom out a little bit. It's going to be right there. So I'm going to delete these circles just because, or delete the point. They might have. I think I'm missing D. I think that got deleted. So D is 4 or 5. 4, 1, 2, 3. Oh wait, no, that's there. A, 4, 3. 1, 2. Okay, that's what's missing. A. So there's A. So now I can connect the points here. H to G. And that's what the rotation is going to look like. And rotations are a little harder to visualize as an entire shape. That's why I suggest, let me delete this, to do a point at a time and envision a rectangle for each point rotating. So like I can show you with, let's say, point C. Let's look at a rectangle for point C. So if I make a rectangle with the X and Y axis and think about how that rectangle rotated, it's a rectangle that goes 6 by 3, and I need to push it into this quadrant, and it's going to be 3 by 6. And it just shows you that's why this point up here, which for some reason is getting cut off by the text. Oh, it's point I. That's why. Is up there. Okay, so you can imagine just the rectangle rotating, and that corner is C, so C prime, or you're calling it I, would be right there. And you can apply the same method for 180 degrees. You just move 2 quadrants. Of course, the 180 point mapping is pretty easy. X, Y goes to negative X, negative Y. So you just make them opposite. That one's pretty easy. And then going 90 degrees counterclockwise, you can do the same method, but imagine the rectangle rotating this way, where the origin is like the hinge, and this rotates down. Okay, I hope that helped. Thanks for watching.